Can you answer me? You can hear me now? Okay. I think my internet connection is unstable. So if it is off also, please will try to join again. Okay. I don't know what's happening here. Okay, no problem. Okay, what we have done is, first of all, we have one gx. Okay. Something gx equal to x squared minus 2. Within the interval minus 2, 3, we have found g minus 2 gives us 2 and g 3. Sorry about the distractions. Keep happening. I don't know. Okay, no worries. Anyway, we can continue our things. Okay. So gx we have had g is x squared minus 2, and also we have seen g dash x is 2x. Also we have g double dash, which is 2, which is greater than 0. So we have minimum value. And at x tends to infinity, we have gx equal to plus infinity as well. If it is x tends to negative infinity, similarly, this is negative infinity squared, no? That is negative infinity, plus infinity. I mean, yeah, am I right? Yeah, this is also infinity, sorry. So we have the pictorial view of something like this. Okay, so this will be x, this will be gx. So since this is a quadratic equation, I have two critical points here and here. Okay, so to find that one, we have to equate that gx to equal to 0. Okay, so if you equate to 0, x squared will be 2, x will be plus or minus square root of 2. Okay, so this will be plus, this will be negative root 2. So this is how also when it is plus, I mean, in here, if you have plus infinity, it is also going in plus infinity. If it is negative infinity also, it is going to the infinity. Okay, this is how the pictorial view. Also, let's say we are equating x. Okay, I'll erase this one. Hope you have copied these things. Please copy these things. So I can erase this one. Okay. So we are doing the fixed point method. Solving method. Okay. So not yet we have come to our solution method. It's just something, right? This is how we're gonna do it. Before that, it is kind of introductions. Okay, shall I erase? Okay, I'll erase. And now, what you have to do is the procedure of to have the fixed point method is you have to take x equal to g. I mean, gx equal to x or x equal to gx. Anything. So what is our you are taking as a gx is equal to x. Okay. So then what is our gx? That is x squared minus 2. No, we have to equate to x. Okay. So can you take it to one side? Let's say x squared minus x minus 2, which is equal to 0. So can you solve this one? This is only a quadratic equation. So what will be the roots for this one? What are the x? We must have 2x roots because of this quadratic. So can you find out? Either you can use your fractional way, or you can use x equal to minus b plus or minus square root of b square minus 4ac over 2a. This kind of techniques you can use now. So if I use xx, so I need to have the multiplication minus 2, addition minus 1. So let me say minus 2, positive 1. Yeah, multiply minus 2. This one, no? So I need to have x minus 2, x plus 1. Am I right? X squared plus 6 minus 2x. Yes, minus 2. Okay. So what will be the answer? So if it is so, we have to equate each 0 or x plus 1 is equal to 0. It will be other way, no? X equal to 2 is equal to minus 1. Am I right? Okay, let me check your answers. Okay, 2 minus 1. 2 minus 1. Yeah, okay, good. So we have this one. So what you do is you are equating whatever comes the gx to x. Then, so these are the roots we have. Okay. If you put that one into x, okay, we have gx is x squared minus 2, no? So if you put this x into it, let's say g2. G2 will be what? 2 squared 4, 4 minus 2, 2. Similarly, g minus 1 is equal to what? 1 minus 2 minus 1. Okay, so you'll have something plus minus things, isn't it? So that means this is called as a fixed point mean. That means write down when you equate generally we can write like this. Okay, gp is equal to p. For x I am putting p. Okay, gp is equal to p. We call p is a fixed point of g. Okay, so here I'm writing generally small p. Okay, gp is equal to p. We call p is this p is our fixed point of this function g. Okay, so what is the technique we use? In this question, you can see gx equal to x. Okay, so this is what the technique we're going to use in our method also. Okay, so that's what I wanted to give you these things. Okay, so please write nicely. I didn't write clearly. I don't know. Okay, so we are equating this part. First of all, we have our gx. Okay, because if you put something number 0, that number, this number, see, minus 2 and 3 our interval. These two also, they are not inside. Okay, should be inside because minus 2 will be here, 3 will be here, minus 1 here, 2 here. So our interval should be here. So when we are equating this one, it is very far away. So to get our fixed point, what we have done is, first of all, you have to check our f of x, g dash x. Then also you have to find the g double dash x. Then if it is greater than 0, we can say, min or mod, max. Okay. So first of all, we have to be taken this one. So if it is satisfied, we go for gx equal to ex, and then we solve it. We find the critical point. These are the roots points. When you put that root points, it is reaching very faster. That is called as a fixed point. Okay. So this is the idea of fixed point method. So let's go back to our method. Okay. Our actual solving method. So I'll continue my lecture notes. Okay. Okay, let's see what it is. So fixed point iterative method. Okay, here we also going to use the way of fixed point method with some iterations. Okay, using the iteration method, we're going to reach our root. Okay, the root of the equation f of x equal to 0. So this is a kind of non-linear, maybe non-linear one variable equations, isn't it? So that's what our goal. So the root of this equation is determined using simple iteration method. Okay. So this method also called as a simple iteration method. Okay. By rewriting the equation in the form, see, that's what I told you. First of all, you have to rewrite this equation in the form of x equal to gx. Okay. So I have sent you this note, so no need to write again, but understand it. So when you are writing, you can understand and write down. Okay. And this function is called fixed point iterative function starting from the guess. So this is what we call it as the initial guess. Initially, we get one x naught of the root computing successively. Okay. So how are you going to compute the real root using from our initial guess is in this way. First of all, you have to take x equal to gx. Okay. Then doing some step, you take x naught. Then the x1, the new x1 will get, let's say this is my x naught. Okay. This is my, let's say gx. Okay. This is my x. So this will be gx now. So let's say this is my, sorry, this part. For example, there is a one nice pictorial view. I'll try again. Okay, let's say this is my function. Okay, so at x naught, I have this one gx naught. Okay, so here also I didn't reach it. Then I go for x1, some x1 that I'm gonna equate to gx naught. Okay, x1 which is equal to gx naught. Again, I go for x2 which is equal to g, something like this. It is rearranging one by one. Okay, so I'll show the picture later. Don't worry about it. Just consider this one. X naught, see x equal to gx. Then initial get x naught. Then you have to find gx naught. Then you have to equate it to the new x1. Again, our new x2 will be our early x1's function. Similarly, x3 will be our earlier function gx2. So similarly, you have to repeat it until you reach, let's say xn is equal to g of the earlier one will be xn minus 1. So that's functional value. Okay. Then let's continue this part. Then there you have to, you can't continue up to somewhere, no. So they may give you some modulus value less than epsilon, or maybe they may ask do 3 iterations, or they may give some conditions to stop, isn't it? So we can see when we doing the exams. Or otherwise, you have to get the, I mean, yeah, this one. You may get something is equal, if it is exactly equal to 0. Okay, let's say my 5th iteration, I'm getting x equal to 0.5321 something. Okay, let's say x5. My x6 also something like that. x3 2 1 again. Okay, then I can stop, isn't it? I don't need to go because wherever I followed, I will get the same answer again. So no need to. I can stop there. Okay. Also, they will ask like this. They will ask the epsilon one. I mean, error something 0.001 something like that, or somewhere approximately 12 to 0, or somewhere you get they don't give you any conditions. You have to stop wherever you are getting the same answers. Similarly, they may ask in the exams and things for the time being, they may ask do 3 iteration like that, or sometime they may ask you the find until 5 significant figures also, like that. For example, 5 or 3 or 5 significant figures. So do you know what do you mean by significant figures? So that's what we have studied, in our first and second classes. Okay, so go back and study what is the meaning of significant figures, how to count from 0.5, 8, 9, 3, 2, 1, 0, 0, 0, something like that, how to find the significant figure. So that I have explained you already. So we just study that one again. Okay, this is the places it may also useful to do it. Okay. Okay, now. Okay, so let me continue the note. This note says, we have a sequence of numbers. Okay, so what is this? What is this notation says? So this xn has been x0, x1, x2. That's a consecutive values, isn't it? There's a series of values, sequence of values. In that, it will be converged to root as n tends to infinity. So it will say, so when you are doing first iteration, second iteration, third iteration, almost like 20 iteration, 21 iteration, somewhere when you are going n tends to infinity, it will be converge. So what do you think converge means? It will be going to the root. There's the differences will be very, very small. Okay. So in that sense, you will reach the root. Then if it diverges, okay, we need to consider another iterative function is equal to hx. Let's say I have I'll give you this idea when we do in the example, okay? So let's say I have equate x equal to gx. Okay, for example, my gx is equal to x squared minus 2. So when I'm getting bigger numbers. Let's say infinity. Okay, it is diverging. Okay, so I need to know it is not the way. So for example, my first iteration 2.5 something, my second one 8 point something, the third one will be 10 point something. So it is increasing to some infinity now. When n tends to infinity, it is going bigger and bigger. So I need to know this is not the way. So my choice of function, it is wrong. So there I need to consider another iterative functions. Okay. So we'll see how it is. Let's say I'm gonna use another hx. Let's say for this one, I can use, let's say, 1 over x minus 1, something like that. Okay. So there's a choices. From your example, you can choose this one or this one, possible one. Okay. Then again, rewrite this fx equal to 0 again and find that hx, which is equal to 8. Then it is always possible to get the convergence sequence by using the following theorem. Okay. So if it is not converging, you have to choose the another way of function x equal to hx. Then rewrite and do the process again. There you can get the answers. So for these convergence things, they are using one theorems. Okay. So let's see how it is working. So let's see that theorem. So that theorem is making easy our work. So I erase this window. Okay, let me continue our fixed point theorem. It calls as fixed point theorem. So from now on, we can use this theorem to easily find our function. Okay. The theorem says sometimes they may ask in the question also, first question, give the fixed point theorem or state the fixed point theorem. So the answer will be here. Okay, I have gave the questions. Sometimes I may ask first question under this fixed point theorem. I may ask to state the fixed point theorem. So bisection also we have one theorem. Okay. So second one may be the questions. So first you have to know how you can write this one in your own word. Okay. So understand it, write in your own word, or otherwise memorize it and write it. Okay. So that's the only way. So let's see what it is first of all. So fixed point theorem says, if the function gx is continuous in the interval a comma b. So continuous in a comma, this is also, they may write in this way also. Okay. Gx belongs to continuous function with the interval a comma b. A comma b is a bounded one. It's a closed one. Okay. Which contains a root, let's say r. R is our root of the equation f of x equal to 0. So they will give you the equation f of x equal to 0. So we need to find the r. R is 1. There we have to find one gx, that is a continuous function within that interval a comma b, and is written as x equal to, we have to find this gx, where we have to equate x equal to gx. Okay, then there's a conditions. This is what I told you earlier. Okay, this we have to find our derivative of gx, and if you take the modulus of that one, it means if you take the yeah, absolute value, it should be less than or equal to 1. Don't write greater than, it should be less than or equal to 1. Okay, so first of all, you have to equate x equal to gx, then you have to find g dash x. That g dash x of absolute value should be less than or equal to 1 in that interval of a comma b. Okay, a comma b may be 0 comma 1 or minus 2 comma 3, any interval, isn't it? They will give you, or you have to find it. Okay, then for any choice, this is our initial choice. Okay, so we have to choose an x node within that interval a comma b. For example, the given interval, you can choose a comma one of the x node. Okay, the sequence of x node. So from x node, you can find x1, x2, x3, like that. So this is the sequence of xn determined by this iteration. So that I have gave you earlier also. Okay, so kth one, k plus 1 value of x will be equal to g of xk. Keep it in your mind. The xk k plus 1 value should be derived from the gx of k. Okay, this is k, this is k plus 1 value. Okay, k is coming 0, 1, 2, 3, can go up to any number. Okay, so then converge to the root f of x equal to 0. Okay, did you understand what I said? So I have already explained you the method of doing. First of all, they will give you f of x equal to 0. Then you have to find one gx, then equate that gx to x. Also, you have to find the derivative of x and find the modulus of x, which should be less than or equal to 1. Then only you can take that gx. Okay, so this is the point. You can choose your gx. So if it is not, then you go for other choice of hx. Did you understand? So again, then if you find the h dash of x, it should be less than 1. Then you can choose this one and leave this one. Okay, so this is the theorem to choose our gx or hx. Okay, then after that, after you finalize these things, these hx or gx, then you go for the initial guess of a comma in x naught, it is inside the a comma b. Then you find the x1, x2, x3 in this iteration formula. That means k plus 1 will be g of xk. Yeah, and then if it is converges, for example, if you get same number, same value x5, x6, you can say x5 is our value. Okay, so this is the idea of doing this question. So please write down whatever I have given you. Okay, meeting also again will be end in 10 minutes, so please join again. Okay. Okay, until that, let's study. So I'll erase these things and let me continue. Okay, this is the working rule to do our fixed point iterations method. So it has also 4 steps. First step says, first write the equation as x equal to gx. So this is not the not just you write x equal to gx. I'll tell you in the when you're doing the example. Okay. So first of all, you have to write x equal to gx, any choice of g. Some books they have used for the g, they have used the phi x. Okay, so everything are same. Don't confuse yourself. So here we have taken as a gx. Okay. Then they say, second step, what you have, first of all, you have to write x equal to gx. In the second step, you have to write find the point A and B such that A less than B, where you have to have the fa dot fb, that means multiplication of function fa and fb less than or equal to 0. This is the step 2 for all the iteration. So that's what for the bisection as well as Newton options, all the things. The second step will be this one. So here also our step 2 will be this. Okay, then give me a second. Yeah, okay. So step number 3 says if A is closer to 0, then FB. If A is closer to 0, then FB, then X naught is equal to A, else X naught is equal to B. So I'll tell you what it is when you're doing exam. Okay. So if you have A, B, we have a choice X naught. If it is F of A is closer to 0, then FB. That means X naught is, we are transforming this X naught to A. Okay. Or otherwise, we transform this X naught to B. Okay. Then step number 4 says, then how you have to use the formula to find the X1. So from the X naught, we have found the initial guess. Then from the X1, you have to use the formula to go to the X1. How you can find X1 is equal to G of X naught now. So from there, we know Gx. So substitute our X naught, then equate to X1. And again go to the X2. Again go to the X3. So you have to repeat until, so the value of f of xi times f of xi minus 1, okay, multiplication of these two is approximately, the modulus will be approximated equal to 0. Okay. So we'll see when we are doing the example. Okay. So that's all the steps. Okay. Step 1, 2, 3, and 4. So let me start our examples, then you will understand. Okay, let's do the same question for all the methods, so you will see the differences. Okay, that's why I choose the same thing also here, because when you see in the examples, what I did was the same example, no? The same example for bisection, as well as Newton raptions, as well as here also, the other one is, okay? So you can see how the methods are changing and the answers are reaching how fast and things, okay? Okay, first of all, let's begin this one. I think you have the question in your module, so if not, just write down quickly so I can explain in the board. Okay. The solutions for this question is, first of all, our f of x is equal to x cubed minus x minus 1. Okay, it's equal to 0. Anyway, so first of all, sorry, they didn't give you 0. So they have given like this. Some question they may give like this, x minus 1 equal to 0. So you have to take this part as fx. Okay. Or some question may give like this. For example, let's say f5 minus 2x plus 4 is equal to 3. Something like that. Okay. So you have to take this one here. You have to equate to 0. Then take it as a fx. Okay. So these are your choices. Okay, erase this one. Okay, that becomes our solution. So our f of x is equal to x cubed minus x minus 1. Okay. Then we have, let's say, we don't have the interval. So let's put a table to, even all the method you can make like this table. Okay. It will give you easy. So my x, my f of x. Let's say if I put 0, 1 or 2, let's see whether I'm getting step 1, step 2, the step 2, I think. Okay. Can you tell me the answers? If you put 0, it will be minus 1, isn't it? You put 1, 1 minus 1, 0 minus 1. Am I right? Yeah, minus 1. So if you put 2, 8 minus 2, 6, 6 minus 1, 5. Okay, so what do you think? We have the choices, no? Plus and minus choices. So I can say this is my interval. Okay, here f of 1 is equal to minus 1, which is less than 0. F of 2 is equal to 5, which is greater than 0. Therefore, root between, if they don't give you the interval, you have to find it in this way. Okay, so I can choose this one, the consecutive one. Rather than this and this, you have to choose this one. Okay, so this is our interval. All clear? Okay, these are we already done. Anyway, now let's begin our thing. So I'll erase this one. I need some space. Okay. Okay. So I'm continuing from there. Okay. So we have our f of x equal to x cube minus x minus 1. Okay. So I need to equate this equal to 0. Our first step, if you see, we have to have f of x equal to 0. So I'm going to equate this one. X cube minus x minus 1 is equal to 0. Okay. So from that, can you find the equation only for x? There are too many ways you can find. For example, if I only take, from this, if you keep x cube this side, all the other terms will go this side, 1 plus x, let's say. Okay. So I can take one of the equation as, for example, 1 plus x, 1 by 3. This is also one of the choice for the gx. Our step 1 is, now only we are in the step 1. Okay, first of all, we have derived our interval case. Okay, this is our step 1. We have to have x equal to gx. So we're going to find out the possible. This is what I told you, whether x equal to gx or hx or any possible. So this is one of the kind. See, I kept x cube this side and take the other from this side. This function also should have the x functions, no? So this is also can be x. Okay, I think our meeting gonna be end. So join again. Okay, so I'll continue from there. Can you find